Okay. So now I will explain how we implement multiple in regression model to predict one output variable based on the multiple input features using libraries. Okay. So as usual, my housing price data is available in my Google Drive, so that I mounted my Google Drive into the Google Colab. Later, NumPy and Pandas libraries are imported. Later, from this path, actually in this location, my house pricing dataset is available in the CSV format. The data available in the CSV format I want to read, and I want to store with a variable called housing. Okay. Here, this first column is the price column, which is we are going to estimate housing price prediction. And the features are area, how much area the house has, number of bedrooms, number of bathrooms, stories, main road, guest room, basement, hot water heating, air conditioning is available or not, parking, number of parkings are required, preferred area, and furnishing status. Well, it is a furnished house, semi-furnished house, unfurnished house. Based on these features, I want to predict the house price. Just I want to cross-verify the complete information of my dataset housing.info. It will give the information. So how many? I have the total 12 input features from area to the furnishing status and one output variable. I have the total 545 values. I have the total 545 rows, 545 samples, and non-null. So there is no null values, there is no missing values against any feature. That means there is no missing value treatment is not required. Okay. But thing is, your computer, your machine learning model, we expect numbers, not text. If you have some text information, you have to convert into numbers. Why I am saying this one is, you can see main road feature. It may be main road yes or no, guest room yes or no. So these are the some like words, right? So you have to convert here in case of the furnishing status. It may be a furnished, or it may be unfurnished, it may be a semi-furnished. So you can't feed the data as it is. You have to convert everything into the numbers. So because of that reason, I want to convert yes and no as a 0 and 1s. And also I want to convert furnished and semi-furnished also. If you observe features like main road, guest room, basement, hot watering, air conditioning, prefer area, all are having the two possibilities, yes or no, 0 or 1. So I need a binary mapping. Okay. And whereas in case of the furnished status, it has the furnished, semi-furnished, and unfurnished. It has the three categories, so that I have to represent some other manner. Now, how I will convert all this information into the numbers we will discuss now. That is the part of the data preprocessing. If you observe the variables list or features list, main road, guest room, basement, hot water, air condition, preferred area, all are having the values, words yes or no. I want to convert them into the 0 and 1. For that one, I am creating a function called binary map. So binary map, that is a user-defined function. And you have to pass the feature. If that feature has the S, that will be replaced with 1. If that feature has the no, that will be replaced with the 0. That's it. That's the function I have defined. Okay. Now, my dataset housing, whatever the variable lists I have mentioned, you have to pass all the list. In those variable lists, if you have any S, it will be replaced with 1. It has any no, it will be replaced with 0 by applying this binary map function. Just I'm applying the binary map function. So when I apply this binary map function to this housing, whatever the features I have mentioned here, in these features, there is a S that will be 1. And if it is a no, that will be 0. That like that it will be converted. So that is called as a binary conversion. See, previously, if you observe main road, yes, like that. But here, under the main road, you have the 1, 1, 1, 1, 1 like this. So if you see the guest room, you have the no, S. So that's why here you have the 0, 0, 0, 0, 1 S. Like that, everything I was converted into the number format. So after that, I want to convert into the categorical conversion. Categorical conversion. Why required categorical conversion? Because in the last column, furnishing status column, it is a categorical values. It is a categorical values. So a furnishing status column has a categorical values. Furnishing status has a categorical values. Categorical values means furnishing status has three values. One is unfurnished, semi-furnished, or furnished. Okay. Now, these are the three values, right? So how we represent this furnishing status in numbering format? For that one, we are using the dummy coding. So dummy coding means for a furnishing status column, actually this furnishing status is only one column, right? So now I am trying to split this one column into the three columns. So one is called as the furnishing, another is the semi-furnishing, another is the unfurnishing. If furnishing status is furnishing, then F will be 0, 1, the remaining will be 0. If the furnishing status is unfurnished, then it will be 0, it will be 0, it will be 1. If the furnishing status is semi-furnished, then this will be 1, this will be 0, this will be 0. Like that, we are converting into the numbers. It's called dummy coding. But however, see, if you represent the furnishing, then you have to use 1, 0, 0. And three values you have to represent one status. Understood, right? I hope. And if you want to represent the unfurnishing, you have to require 0, 0, 1. And if you represent SF semi-furnished, you have to keep 0, 1, 0. Three columns, right? Instead of that one, I want to drop one column. I want to drop one column. I will drop this one. That's okay, no problem. Why? That means if this value and this value is 0, that means it is a furnished house. If this value is 0 and this column is 1, then it is called as the unfurnished house. If this column is 1, this column is 0, then we can call it as a semi-furnished. Okay. That means if it is a 0, 0, fully furnished. If it is a 0, 1, it is unfurnished. If it is a 1, 0, it is the semi-furnished. So like that, whatever the furnishing status you have is represented in the numbering format like this. Okay. So that's what I am using dummy coding for the categorical value representation. So you can see here categorical representation. You can see here status, that is the furnishing status equal to pd.getDummies furnishing status draw first. So what it will do is it will convert these three dummies. Three columns will be splitted. Next. Okay. And whatever the three columns are generated, that will be concatenated. That will be concatenated to your original data. This is the original housing data, right? For this original housing data, three more columns will be added. One is called furnished, semi-furnished, and unfurnished. Understood? That's what this is the representation is. Next is once we add furnished, semi-furnished, and unfurnished, there is no need of this furnishing status column. Just drop it. So that is dropping the furnishing column. Okay. And remaining three columns, we are dropping the first one here. We are dropping the first data. That means furnished status will be dropped. So what happened? What simple? What nothing? It's very simple, right? See, don't confuse much. Furnished status, we have the furnished, semi-furnished, and unfurnished. So when you are writing this piece of code, get dummies means it will create against the furnishing status. It will create furnishing, semi-furnishing, and unfurnishing with values like this. Later, you can see here one more line that drop first true. That means you have to drop the first column. Then you have the only these two columns, and these two columns you have to add it to your original data set. After adding the two columns to your original data set, there is no need of this furnishing status column. So that's why I'm removing this furnishing status column from this data set. So if you observe, if you execute this code, you can see your data set, how it looks like. Previously, here you have the furnishing status column that is dropped. And here adding the furnished, semi-furnished, unfurnished, and but dropping the furnished. I'm dropping the furnished. So finally you have the semi-furnished and unfurnished columns. So semi-furnished false, unfurnished false means it's the furnished house. If it is semi-furnished room means it is a semi-furnished house. If it is a unfurnished pot room means it is the unfurnished house. So like that. Again, false means 0 and true means 1. That's it. It's a number again. Okay, by default it will take the 0 and 1. True false case. So this is the how we are converting the data. That means whatever the word format information is available, we have to convert them into the numbering. In the number format, we have to convert. Okay. Now, data split. This you know, right? These all these things are you are aware very well. So whatever the housing data set I have, I am passing the complete housing data. Here I'm not passing the input and output. If you're passing the input and output from the data, then it will give the training input, training output, testing input, testing output, like X train, Y train, X test and Y test. But here I'm not splitting that information. Only I am passing the whole data set as a housing so that it will split the data only for the training and testing. So DF train and DF test. So DF train contains both inputs and outputs inside, not separated now. And DF test also has both training and inputs and outputs inside, not separated. This is the input, this is the output. Previously X train and Y train. Now under the DF train, you have the both X train and Y train, both inputs and outputs. And DF test, we have previously we have the X test and Y test. Here you have the both X test and Y test. Both are in the DF test only. Later we will split it. This is another way of representation. You can try any way. Okay. Test size is 0.3. No, test size is 0.3 means 30% of testing data, 70% training data, 70:30. Random state equal to 100. And I'm trying to apply min-max scalar for the data normalization. So for the data normalization, there is no need of data normalization for the main road, guest room, basement, hot water, air conditioning, parking, not prefer area, all the things, because all the values are between 0 and 1 only. And remaining like area, all the things I am trying to for area column, for bedroom column, for bathroom column, for storage column, for parking column, for price column, I am trying to apply the min-max scalar method. So if you apply this min-max scalar method, so this is called the normalization. I said, right, you have to normalize the data between the 0 to 1. There's the different values. So that price is in terms of the what's called in terms of lakhs, and whereas area is in terms of the thousands, remaining are some single digits, different value distribution. So I'm trying to scale down all the values in between the 0 to 1. Okay, so whatever the features, whatever the features I have mentioned here, what are the variables I mentioned here? For all the values, you have to convert into the scalar. Scalar is nothing but the min-max scalar. Min-max scalar is nothing but it's one of the method available in the Python to scale down the all the feature values that are mentioned here in the range of 0 to 1 in both training data and also in the testing data. So previously, if you observe how the values are looks like, carefully observe how the values are looks like. Now after normalization, you can see the values, how the values are looks like. See, in the price you have the lakhs, but now you have the 0.1, 0.6 like that. See, bedrooms you have 2, 4, 2, 2, 1, 1 like that. Here you have the 0.4, 0.4 like that. So all the values are scaled down between the 0 to 1 after applying the data normalization. After applying the data normalization. Okay. Now I want to separate now I want to split the data like a training data and testing data in both, input and output in the training and testing. DF train has the training data, DF test has the test data. In the training data, POP, that means you have to take price column. You have to take price column. So that information you have to store in the Y train. That is nothing but output. So after removing the price column, whatever the things are available, that is called as your input X train. Similarly, from the text data, remove the price column and send it to the Y test. That is the output. And after removal of the price column, in the test data, whatever the data is available from the area to unfurnished, all the data is going to the X-test as the input data during the testing phase. So this is how. So previously in the simple integration model discussion, so that splitting of X-train, Y-train, X-test, Y-test are done in this stage only. But here I am doing in another way. First, I am splitting the data for the training and testing. Later, I am splitting the data, training data as input data and output data, testing data as input data and output data. Later, I split it. Up to here, data pre-processing is completed. Data split is the last step, right, in the data pre-processing technique. That's completed. So from here, it is easy for you. Actually, when I apply the multiple integration model, that too only two features, two input features and output feature, I wrote around 18 lines of code. But see, in this case, how anyone can respond. For in this project, if I develop a multiple linear regression model, how many number of model parameters will be? In this project, suppose if I ask you to write a gradient descent algorithm to train your multiple integration model for this project, for this problem, how many number of model parameters will be? Anyone? This is the data set. You can see data set. This data set contains total 13 columns. Out of 13, 12 are the input features, 1 is the output. Out of 13, 12 are the input features, 1 is the output. Now tell me what are the total number of model parameters? What are the total number of model parameters in this multiple linear regression model? If you want to design or develop a multiple integration model for the house price prediction based on this data, what are the total number of model parameters? I'm asking because this type of questions will be come in today's physics examination. Anyone please respond? Solve. 12, we have the 12 input features, so that 12 coefficients like M1, M2, M3, so on, M12. In addition to the 12, we have the one bias parameter also, C. So we have the total 13 model parameters, 12 plus 1, total 13 model parameters. If it is a 13 model parameters, you can assume how code looks like. 13 gradients, 13 step lengths, 13 model parameter updations, and 13 model parameter initializations. So your complexity of the code will be increases when you are writing the code from the scratch. But when you are using the libraries, that's fun. So see, same steps what I'm using for the simple linear regression model. From sklearn.linear model, linear regression, same. I'm creating an object, regressor. I'm creating an object of my linear regression model as a regressor. You can use LM also, that's what we are using in the previous case. Here I'm using the regressor. Your choice, your name also you can keep here. Now, if you want to train, where we see around 18 lines of code in the previous example, but here single line, even though you have the 13 model parameters, you have the 12 input features, just a single line is sufficient to train your machine learning model. But in the backend, the code what you have written, similar code will be run in the backend. In the backend, similar code will be run. Right? So I'm importing the linear regression model. I'm creating the regression model objective, and dot fit means to train the model. Maybe in the quiz examinations, we will ask. So which method will be used to train your machine learning model? Then you can tell dot fit. Maybe sometimes I will ask which model, which function in the Python can be used to predict. Then you can say dot predict. So you have to know which function is used for what purpose. If I ask which function in the Python will be used for the data split, you can write train underscore test underscore split. Okay, so you have to remember all the things. So just I am creating the, this cell is not executed. That's why it is showing that text train is not defined. Now it's okay, I think so. Done. So model is trained, completed. So once the model trained, what we are getting? We will get the model parameters M1, M2, M3 up to M12 and C. So M means it contains the coefficient information, and whereas C contains the intercept. Coefficients are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 coefficients we have actually. And we have the model parameter also, including the model parameter. And here, these are used to predict the outputs. So if you feed the input data available in the test to your trained model with a dot predict, it will give its outputs, YP predictions. These are the predictions by your linear regression model. These are predictions by your linear regression model. And X-train, it is nothing but the X-train. What about this YPRED underscore train? YPRED underscore train, nothing but the predicted output by my multiple linear regression model for the input data coming from the training set. And YPRED test, nothing but the predicted outputs by my multiple linear regression model from the input data coming from the test set. So you got the YPRED test and YPRED train. Why you require these two? In order to evaluate the performance of my model in terms of the mean square error, root mean square error, and mean absolute error. No need to calculate all. You can calculate any one feature also, not a problem. But I'm telling how to calculate different type of errors I'm mentioning here. So whatever this piece of code we already discussed. So this is the calculation of the root mean square error, and also mean absolute error for the training data. So this is the training errors. So these are the training errors I am getting. Similarly, these are testing data because I'm testing the actual output from the test data and the predicted output from the test data. Okay. I hope you understand. So let's assume you are very happy with your testing errors and also with your test training errors. You and your client also very happy. Then what you have to do? To go for the deployment. So go for the deployment is nothing but first of all you have to save your trained model. First of all, you have to save your trained model. You have to save your trained model. So to save your trained model, even though what process we applied for the simple linear regression model, you can use the same thing. So import pickle. So this is used to save your machine learning model in the .pkl format. .pkl format. If you want to store your machine learning model in the .pkl format, you have to import your import pickle. And here I'm writing my name is model.pkl. So already where our trained model is available with an object name of regressor. So that trained model I want to dump into this file and I want to save that file here. So if you run this code, then here you can able to see model.pkl file, which is nothing but the trained multiple linear regression model for your house price prediction. Now forget about all the things what you did till now. Just only concentrate here. Wherever you want to install your application, deploy your application, just download this PKL file and deploy in the backend of your application. Deploy in the backend of your application. Download from here and save it on your PC. And wherever you want to deploy this model, you can directly deploy this model. So, okay. Now we will discuss about the deployment. Let's assume for the deployment means, so first of all, we have to write a code to get the information from the user. That means user will ask, so I want this square feet area of house is required. These number of bedrooms are required. I need these number of bathrooms are required. I need air condition. I don't need parking. I need some preferred area. My house should be near the main road. So like that, some features he will enter and your model will predict the price, estimate the price. Okay. So this complete code I have written for the front end application, like a front end. So what it will do here, list of columns equal to housing dot columns. That means in the housing data set, whatever the columns you have, all the columns you have to list out. Like price, all the things. Now I am preparing a data frame. Name as input data. In the data frame, whatever so I want to prepare a data frame with the name of input data. I want to prepare a data frame with input data with the same columns that what I have in my data set. With these columns, I want to prepare a new data frame. So the data frame name is input data. Whereas input data, I don't need price because user will expect the price. He will not give the price information. So just drop this price column from my input data. Drop this price column from the input data. Now, whatever the remaining columns are there, area, bedrooms, bathrooms, all things, these values should be given by the user from the outside, from the front end. From the front end, all these values will be given by the user, and those values are stored in this input data frame. In the input data frame, all the values entered by the user will be stored. Okay. And so he will enter input, enter the semi-furnished status, input, enter unfurnished status. If the user wants a semi-furnished house, he will give 1 at this point. If the user want furnished data, unfurnished house, he will enter 1 at this point. Okay, you will enter 1 or no. No, yes or no, right? Here we have the false or true, yes or no, you can write here. If he enter here also no, that means semi-furnished no, unfurnished no means by default it is the furnished status. Okay. Next, after entering all this information from the front end by the user, you have to do some backend code. What the backend code? For the main road, guest room, basement, hot water, air condition, prefer area, semi-furnished, unfurnished, he will enter yes or no like this, right? So wherever user is entering yes, you have to replace with 1. Wherever user is entering no, you have to replace with 0 because your machine will not understand yes or no. It will understand only zeros and ones and numbers only. Okay. So this is the your binary map function, and I'm applying that binary map function in this input data for these features. Because these features have the values either yes or no. If it is yes, it will give the 1. If it is no, it will give 0. And we train my multiple linear regression model based on the normalized data, right? Normalized data. So at the time of the deployment also, user will enter the normal data. That means he will enter the 12,000 square yards house. But when you are giving the data to your backend machine learning model, you have to normalize it. Normalize means yesterday, I think on the first day or second, I told normalization means actual value minus minimum value divided by maximum value minus minimum value. That's what I am doing for every feature where we require the normalization. Where we require the normalization area, bedrooms, bathrooms, stories, and parking, here we require the normalization. Here, your actual value minus minimum value divided by maximum value minus minimum value. Like that, we are normalizing the data. Once everything is finished, now once everything is finished, now what we have to do is, so this up to here, the complete thing is finished. Okay. Now I want to remove this part. I don't want to use. Done. Okay. Just is the front end asking enter area. So I don't have exact value. So we will do one thing. I will capture from my mobile. Yeah, somewhere I write. Okay. Now we will give the values. That means let us I am the user. I am searching for the house. So I will enter the some values. I will enter some values. Okay. So what is asking? It is asking the enter area. So I want to write 7,420 square yards. And asking number of bedrooms. I will enter 4. It is asking number of bathrooms. I will enter 2. And it is asking stories. I think 3. And asking whether it is required near the main road or not. It is asking near main road or not. So I will enter S. I want the house near main road. And require the guest room. No, I don't want the guest room. And require the basement. No. And heating, no, I don't want. And air condition, that is I required. Parking, so 2 parking areas are required for me. Preferable area, yes, I need. And it is a semi-furnished? No, because I want the furnished house. Unfurnished? No. So that's how I'm giving the data. So now data is ready. Now you have to this complete data going to your backend application. Backend, you have to keep your model. So now you whatever the model you saved already, you need to load it. You need to load the model. So model equal to pickle.load. You have whatever the PKL file you have to load that model. And model.predict, you have to pass your input data. Then the prediction will show nothing but your price. The prediction will show your price. Somewhere mistaken. It's okay, okay. Some data I have missed here. So forget to enter the some data to enter. Or maybe wrong data I have entered. But okay. 1 minute. Otherwise I will do. I will go back to my original file and open. Yeah. So I will show something like this. Okay. So after running this complete cell, so it is asking how much square area it is required, 7,420. Number of bedrooms required 3. Number of bathrooms required 3. Number of stories required 2. And main road S. And I want the guest room. And I want the basement. And I don't want a hot water. I don't want air condition. And I need the 2 parking areas. Prefer area S. And semi-furnished no and unfurnished. Sorry, unfurnished no. That means semi-furnished no and unfurnished no nothing, but I want a complete furnished house. So like that, I have entered the data. Maybe I missed it somewhere in the previously. So once I entered all these values, now you can see here, load your save model. Already what are the model we are saved, that model I am loading. And to that model, I am passing this complete input data. To this model, I am passing this complete input data. And once this input data passing to your model.predict function, so it will give the prediction. Prediction means it will give the price. So in the prediction, you have the only one value that is represented with the 0. 0th index means only first value. So the 0th index will represent the price value. But here you may have some doubt, sir, why you are doing all the things? Price is coming already, right? So we can print the result value as a price directly. But why you are doing all the things? Anyone can give the answer why I am doing this stuff, result into something like this. And later I am printing the price, not directly result as a price I am not printing. Why? Anyone is able to? So my question is, so here the result is coming, right? So I can print house price, the result directly, but in between why I am multiplying something with the results and that is stored in the price and that price is printed here as the house price. Any idea? But if you observe here, maybe I have any idea why I am doing all the things? Because whatever the prediction coming from your machine learning model, that is based on the normalized data. Because we are normalizing the price column also. So the price values are coming between the 0 to 1. The price values are coming between the 0 to 1 from my machine learning model. Suppose your machine learning model, your application showing that your housing price equal to 0.5. So everyone will laugh, right? The actual price are in terms of the lakhs. 17 lakhs, 35 lakhs, 40 lakhs, and your model is predicting as a 0.2, 0.3, 0.5 like that. It is not a true value, right? So it is a normalized value. So whenever you are displaying in front of your user, you have to back it. That means you have to denormalize it. So to denormalization, I am doing this one. How we do this denormalization? Like how we do the normalization actually? X norm. That means sorry. So X norm, that's equal to normalized value. X norm, that's equal to normalized value. That's equal to actual value minus minimum value divided by maximum value and minus minimum value, right? So your machine learning model will give the normalized value, output, normalized value. But don't show this normalized value to your user, who are using your application. If you display this normalized output from your machine learning model on the page, it's showing the value between the 0 to 1, everyone will laugh. Do you think 50 paise, 0.5, 0.5 rupee house price, right? So what you will do, you will get the normalized value. From that, you can get the actual value. How you get the actual value? So actual price equal to your normalized price multiplied by maximum price minus minimum price plus minimum price. So based on this one, we will get the actual price value. That's what I am doing here. Your normalized output multiplied by actual maximum value, you can see maximum value minus minimum value. Maximum value minus minimum value plus the minimum value, plus the minimum value. Okay. Okay. Now I hope you understand how we are using the Python library for implementing the multiple linear regression model. Then fine. Now I will move to the next machine learning model, that is called as the polynomial regression model. Now we are, so simple regression model is over. We discussed in mathematics and Python implementation, library implementation. Multiple linear regression model completed, mathematics and from the scratch implementation and library implementation. Now we will discuss about the polynomial regression model. Polynomial regression model. Okay. So what is the polynomial regression model? So let's assume it is somewhat different polynomial regression model, but I will say, I'm trying to explain in simple manner. Let's assume I want to predict an output y based on the input x. That means you have the x1, x2, x3, x4 inputs, and corresponding outputs are y1, y2, y3, and y4. Okay. Now fine. So if you apply polynomial regression model to estimate output y based on the input x, then what it will do is, first it will develop polynomial features. It will develop polynomial features based on the degree you mentioned. Based on the degree you mentioned. So what is this polynomial features, sir? You may ask. For example, in the polynomial regression model, if I mention one hyperparameter as degree, there is one hyperparameter that is called as degree. So actually linear regression model means you are trying to build a linear relation between your output and input, right? Y equal to mx plus c or y equal to m1 x1 plus m2 x2 plus c. They're the linear regressions. We are building a linear relation between the input and output. But in case of the polynomial regression model, we are trying to build some polynomial or nonlinear relation between the inputs and outputs. We are building the polynomial nonlinear relation between the input and output, right? So in order to build the nonlinear relation, there is one hyperparameter that is called as the degree for a polynomial regression model. If you say degree equal to 2, if you say degree equal to 2, then this whole data set will be converted like this. How? The y will not change. The y will be like this: y1, y2, y3, y4. But yeah, the degree is 2. So there are two features will be coming. Two features means degree 2. That means up to x square. One is x, another is the x square. There are the two features will be developed. Suppose the degree is 3, then you have the x cube. If degree is 4, then you have the x to the power of 4. Okay. But for our demonstration, I will take only degree 2. I want to take only degree 2. If degree 2, then polynomial features are, one feature is the x, another feature is the x square that will be developed. Right? So that what happened? X means same. That means it is x1, x2, x3, and x4. But what about x square? That means second order. Second order means it will be x1 multiplied by x1, that is x1 square. It is x2 multiplied by x2, that is x2 square. It is x3 multiplied by x3, that is x3 square. And x4 multiplied by x4, that is x4 square. Right? So that will be developed like this. That will be developed like this. Understood, right? Okay. So now what happened? Even though you have the only one feature, one input and one output, but if you apply polynomial regression model with the degree 2, then the number of features becomes 2 and one output variable. Okay. Now, please, someone can respond. Suppose I want to predict the load at 5 o'clock today, next hour load, based on the previous hour load. I want to forecast or I want to predict the next hour load based on the previous hour load. That means one input, one output. And I want to apply the polynomial regression with a degree 5. I want to apply the polynomial regression with a degree 5. If that is the case, then what is the size of your data set which is given to your polynomial regression model? What will be the size of your data set which is feeding to your polynomial regression model? Anyone? I will repeat once again the question. The question is, let's assume I want to forecast the load at next hour based on the previous hour load data. And I want to use the polynomial regression model with the degree 5. Then tell me how many polynomial features will be, how many input features will be in a data set that is given to your polynomial regression model. Anyone? Okay. So if it is a degree 2, the number of polynomial features equal to 2. One is, if degree 2, you are going up to second order, x and x square. If degree 3, you going for x, x square and x cube like that. Now you have the 2 input features and the 1 output feature. Now it looks like again multiple linear regression model. Again, it looks like a multiple linear regression model. So one model you have the x square feature, that is the x1 into x1 will be going. Another feature will be only x, that is this x1 will be gone. Now here you have to multiply this one with m1 and you have to multiply this one with m2, because we know, right? We know m1 into x1 plus m2 into x2 plus c bias parameter. Now you have to add these. You have to add these two, m1 x square plus m2 x, and you have to add one bias parameter that is called as the c, and this will be your prediction yp. This will be your prediction, that is the yp. I think it's clear, right? So the polynomial regression model is nothing but the combination of your linear regression model with the polynomial features. So polynomial regression model, for PR model, polynomial regression model is nothing but the polynomial features, that is the x and x square, x and x square and x cube, x and x square, x cube, x to the power 4, based on the degree you mentioned, plus multiple linear regression model. So the regression model is a multiple linear regression model. That features which are coming is the polynomial features. So the combination, so you can hide these two parts. It can be called as a PR model, polynomial regression model. And the rest of things are same. Rest of things are almost same as usual. So this is like one feature, x1. This is like another feature, x2, and this is your output. So predicted output yp equal to m1 into x1 plus m2 into x2 plus bias parameter. See, there is a prediction. And whatever the prediction you have, let us assume if you are passing the first sample, let us assume you are passing the first sample. So then once you are passing the first sample, x1 into x1 square, that is called as the first feature, and x1, that's the second feature. If you are passing this one, these two values, whatever the after mathematical processing, whatever the prediction you are getting, that prediction is compared with your actual output, and it will calculate the error between the actual output and your predicted output. Based on that error, your model parameters m1, m2, and c will be updated. From here again, it's like a look. It's same as your multiple linear regression model. It is same as your multiple linear regression model. So, but the only difference is, in this case, we are considering the polynomial values of your input feature. Actually, your input feature is this one. Now you are generating the polynomial features, and these polynomial features are given as the input features to your multiple linear regression model in case of the polynomial regression model. In case of the polynomial regression model, whatever the original input features are there, they are converted into the polynomial features based on the degree you mentioned. And these polynomial features are given to the your linear regression model, multiple linear regression model. That's it. And from here, rest is same. Rest is same. So whatever we discussed in case of the multiple linear regression model, the same thing will be happening here also. Same thing will be happening here also. Same code, same discussion. So here it is a x1 input 1 is nothing but the small x1 whole square, and capital X2 is nothing but the small x1. So like this is one feature, this is another feature, but this time these are the polynomial features. These are the polynomial features. Hope you understand. Why is the polynomial features? You have the square term, sometimes you have the cube terms also if it's the degree 3. You have the sector 4 also if the degree equal to 4. Like that we have. Okay, so in other words, you can call yp equal to m1 into capital X1 nothing but the x1 square. That means small x1 into x1. That is the small x1 square plus m2 into capital X2 nothing but the x1 nothing but the small x1. Let's see. So this is a polynomial degree 2. For suppose if the degree equal to 3, then your prediction will be yp equal to m1 into x1 cube, m2 into x2 plus m2 into x2 square, x1 square plus m3 into x1 plus c. Again, it's the polynomial feature. That's how it's happening. Actually, here it looks like a linear. But what is the x1? Capital X1 nothing but the small x1 square. If it is the degree 2. If it is the degree 3, small x1 small x1 cube. Like that it will be happening. That's why it's called as a polynomial regression model. Polynomial regression model. For example, if you have still confusion, suppose I want to predict y based on x value 2, x value 3, x value 4, x value 5. Corresponding output values are 3, 4, 5, 6. Let us assume, just I'm saying. Okay. So now let us assume I want to train a polynomial regression model with degree 3. Let us assume degree 3. So if degree 3 means output is as it is you have to keep. That means 3, 4, 5, and 6. Degree 3 means so you have to keep x square, and x cube. So you can call it as a x1, you can call it as a x2, you can call it as a x3. So x means what is the x value for 3? What is the x value input? 2. 2 square 4, 2 cube 8. So this is a x3 equal capital X3 equal to 8, capital X2 equal to 4, capital X1 equal to 2. If these 3 are the input features, my output will be 3. Now it looks like a multiple linear regression model only, right? Again here, if you go for this one, it is a 3, x equal to 3, 9, 27. Here it is a 4, 16, 64. Right. If it is a 5, 25, and 125. Right. So now this is the one feature x1. This is another feature. Sorry, this is one feature x3. This is another feature x2. This is another feature x3. So there is a 3 input features and 1 output features. Again, now it's like a multiple linear regression model. Now multiple regression model means so your model will be like this. Now it's a polynomial given to your multiple regression model. So is it x1, right? X1. This is x2, right? So x2. This is x3, right? So this is x3. Now going back to M1, M2, M3, and plus in this one, and again it is a plus bias parameter C. This will be your prediction. So X1 is nothing but the small x, right? X. X2 nothing but the is the x square value, this column, and X3 nothing but the x cube column. Right. So there are 3 input features, and on output, it is a multiple linear regression model. Same process what we applied in the earlier, you can apply here also. I don't want to explain this algorithm again. The same algorithm you can apply now. The same algorithm you can apply. Same algorithm from this step number 1 to from this step number 11, you can keep as it is, no change. Okay. So this is how we will keep everything. Now we will discuss the implementation. Now we will discuss the implementation of polynomial regression model from the scratch based on the mathematics and also using the Python libraries. We'll discuss later. Yeah. Polynomial regression. Yeah, polynomial regression. Yeah. Okay. So now see, let's assume I have input features A and output feature B. I want to predict the value of B based on the value of A. So A values are 0.12, 0.9, B values are 3.12, 5.52, some values are there. I want to use the polynomial regression model, and this whole data is available in my Google Drive, so that as usual, I want to mount this one. So drive mounted, import libraries, and import the data from this path. In this path, I have this data. This data is available in this path. Just I am downloading it. One feature is A, another feature is B. So this is the data of A column. That means whatever the information available in the A column, that is displayed here. That is the input data. Okay. Actually, this is a very small data, and that I have prepared for the workshop purpose. So there is no outliers. Generally, we have to follow all these steps, but we don't have much time. That's why I'm skipping. But the code is still available with you. I'm remove this outlier detection and outlier treatment, missing value detection, missing value treatment. That's over. So after that, what we have to do? You have to split the data. We have to split the data. So if you want to split the data, we know. So you have to use the train underscore test underscore split. And for the train underscore test underscore split, you have to feed the input data. That the input means A, and you have to feed the output data, that is called B. And you have to feed the test size 2.2, that is called as the 20%. So if you pass this information to the train underscore test underscore split method, it will throw 4 arrays, 4 matrices, 4 arrays. Xtrain means input data in training set. Xtest means input data in the test set. Train means input data in the output data in the training set. Test means output data in the test set. Okay, so I'm splitting the data like this. Now tell me, yeah. So actually, I hope you understand clear, right? Now, not mentioned. I'm not sure whether I mentioned or not here. Not mentioned here. But what the thing is, I want to build the polynomial regression model with degree 2. So degree 2 means I have the only one input feature. If the degree is 2 means I have the two features. One feature is against the A column, and the feature is against the A square column. So two input features, and as usual, we have the one output feature that is called as the B. I think you agree, right? This is A and B. And if I so I have the two columns, input column A and output column B. I want to build the polynomial regression model with the degree 2. Degree 2 means you have the two features. One is the A square, another is the A, and output is as it is only. If the two input features, how many model parameters will be? How many model parameters for A square? One model parameter is M1. For A, another model parameter is M2. And we have the one bias parameter also, C. So total M1, M2, and C bias parameter. We have the total 3 parameters. So we have to initialize all these 3 parameters. That's what I am doing here. You can see 3 parameters, right? M1 randomly initialized, M2 randomly initialized, C value also randomly initialized. All are randomly initialized. Okay. And eta value equal to 0.01. Eta value equal to 0.01. That's the learning rate. A maximum number of epochs I have mentioned as a 1 lakh. Some random I have taken like this. Okay. Now, so what is the next step as per our multiple linear? Even though it is the polynomial regression, because we are taking the polynomial input features, but finally the algorithm will be same as your multiple linear regression model only. So in the multiple regression model, you have to calculate the gradients, right? So it is to calculate the gradients. You are aware of all the things. In the gradients, how your equation will be looks like. So your prediction, your gradient, how the first calculate the error equal to 1 by 2 y minus yp whole square. So E equal to 1 by 2 y actual value minus. Okay. And M1. So M1 into A square minus M2 into A minus C whole square. Right? So where A is the input. Where A is the input. I think, okay, where A is the input, right? A is the input. Right? So what is the gradient with respect to M1, gradient with respect to M2, gradient with respect to C? That's equal to, these two come forward, 2 will be cancelled. Then we have the y minus M1 A square minus M2 into A minus C. And with respect to M1, I am differentiating. So minus A square. Right? Similarly, GM2, what is the value of GM2? GM2 means dou E by dou M2. And means this is the dou E by dou M2. M2 coefficient is minus A. Then what we have? Minus y minus M1 A square minus M2 into A minus C into A, because M2 coefficient is A. What about the GC? Dou E by dou C. C coefficient is minus 1 only. So we have the minus y minus M1 into A square minus M2 into A minus C. I think you agree about these three equations. Same thing I implemented here. M1 means I can write it as a GM1, gradient with respect to the M1 equal to minus 1 into, if you have any difficulty, you can do one thing. You can pass A and B values, right? Here we are writing not Y, it is the B, right? Sorry. The actual value is nothing but the B. Actual value is nothing but the B. So you can keep it as a B here, keep it as a B here, keep it as a B here, B here, B here. So your input and outputs are A and B, right? So I will edit here. Input and outputs are A and B. Now, whatever the GM1 equal to minus B. That means it is the B. Minus M1 into A square. A square means A into A square. Again, M2 into A. So M2 into A minus C into A square. A square means A into A. And similarly, what is the M2 derivative? That is called GM2. So what is the GM2 value? So GM2 equal to minus 1 into B. So here you have the B minus M1 into A square, right? M1 into A square means A into A, M2 into A, and here also A. You can see here M1 into A square minus M2 into A minus C into A only. And last one, C derivative. C derivative means GC, that's equal to minus 1 into, here B we are passing, B minus M1 into A square, M2 into A, that's it. You can see here M1 into A square minus M2 into A, the same thing is reflected here. Finally, you have to can keep small gc for uniformity, that's it. Nothing wrong. Okay. Now you have to return your gradient with respect to the M1, gradient with respect to M2, gradient with respect to M3. Right? That's it. Not M3, sorry. Gradient with respect to C. Now run this one. Done. So after gradients are completed, now what we have to do? Again, your go back to your stochastic gradient algorithm. Outer for loop iterations, inner for loop samples, outer for loop iterations, inner for loop samples. So outer for loop iterations, maximum iterations, inner for loop training samples. And you have to calculate your choice. Okay. You have to calculate I will keep it aside. You have to calculate the GM1, gradient 1, and you have to calculate the GM2, and also you have to calculate the GC. And by using this gradient function, you have to pass M1, M2, C, where A and B are coming from your training data and X-train and Y-train. X-train contains the training inputs. Y-train contains the training outputs. That's what we are required here. A and B nothing but the input and output, right? Input is X-train, output is the Y-train. Whatever the sample we are passing, the corresponding sample input, corresponding sample output will be going back to your gradient. It will give the gradient values. Once you got the gradient values, you have to calculate the delta M1. How we calculate the delta M1? So delta M1 equal to minus eta multiplied by GM1, right? So these things we already discussed. That's why I am writing fastly. So delta M2 equal to minus eta GM2, and delta C equal to minus eta into, I think, GC, dou E by dou C. So once you have this one, you have to update the model parameters. So M1 equal to M1 plus delta M1, and M2 equal to M2 plus delta M2, and C equal to C plus del C. So you have all these informations. All right. So what? Gradient calculation, step length calculation, model parameter updation. This should be repeated over the complete iterations. So this is the part of your training, but it is showing some error because it's showing that maximum number of iterations not initialized. So this cell I forget to execute. So now you can start here. Fine. So that's fine. So finally, my model was trained. Now after model training, what we have to do? We have to we have to observe the performance of the model during the training and testing. If you want to observe the performance of the model in terms of the errors during the training and testing, what you have to do? You have to calculate the prediction during the training and prediction during the testing. Okay. So this part we already discussed in the multiple regression model, and but only one change is whatever the value, input value we are taking from the xtrain, whatever the input value we are taking from the xtrain, that should be squared with the M1 multiplication and I, that means into I. Why I am doing all the things? Because you can see here, we already discussed it. This part. So yp equal to M1 into x1 square. That's what I'm M1 into I square. You can keep I here. Otherwise, you have any doubt with x1 square, x2, x1 like that, no? So you can keep x here. X in x train. Then you can write x square. X square means x into x. So M1 into x square and M2 into x. Then, so whatever the prediction you are getting, that is the Y prediction. That prediction is stored in this prediction array. That's it. Similarly, for test data, whatever the x is, input is coming from the x test, you have to find M1 x square, x into x, M2 x, M2 x. So whatever the prediction is coming on the test data, that will be stored here. That's it. So after getting the prediction on the test data, prediction on the train data, actual where we have the actual training output. So we have the actual training output in the Y train, actual testing output in actual output in the testing in the Y test. So we have all the things. So now compare the predicted output and actual output during the training and during the testing. Then you will get the errors. So this part I already explained. So this whole cell, we are passing the Y train and Y pred train so that this will give the training performance errors or training errors. So just I'm running this one. I'm getting the training errors again almost equal to 0. See, 3 into 10 to the minus 5, almost 0. 2 into 10 to the minus 5, almost 0. So training errors are almost equal to 0. See the testing errors. Testing errors also almost equal to 0. That means I am happy with my model performance and my client also happy with the model performance. Then what I have to do? I have to deploy the model. So deploy the model means we will ask the user to enter the input value. We will ask the user to enter the input value. Okay. And once the input value is entered, we have to get the prediction. How we get the prediction? M1 into x square plus M2 into x plus c. That's what I have written here. Prediction or estimation equal to M1 into x square plus M2 into x plus c. Whatever the estimation we are getting, we have to print it here. So let's assume from the data, let's assume I want to give 0.5. If I have to give the 0.5, that should be answer should be 4. If the input is 0.5, then the output should be 4, I think so. So input is 0.5. So I'm expecting output 4. So I'm getting the approximately equal to 4. 3.99 approximately equal to 4 only. Right? I think it's clear, right? Okay. So this is how we can train the polynomial regression model. We have to train the polynomial regression model. So polynomial regression model is nothing but the combination of polynomial features with multiple linear regression model. That's it. Okay. So I think you are clear with the polynomial regression model also. Okay. Now, and one more thing I want to talk with you because a few participants, that's fine. Up to here that the delivery of the content is completed. So I want to stop this recording, but I want to share one thing with you. Okay. Some participants are asking how to submit the programming assignments. Simply do one thing. Click on Google. Take Google Colab. Okay. So now click on this Google Colab. You can find a new notebook. So click on this new notebook. And let's resume. I don't want to discuss about the programming assignments. We already do. I want to take some other. Like let's assume I want to minimize f of x equal to 2x cube plus 2x cube plus 3x plus 4. I want to minimize this function. So what the gradient of this one? Dou f by dou x. What is the gradient? So gradient equal to 6 into x square plus 3. This is the gradient. Okay, remember these two. Okay, now I want to write a code for the gradient descent algorithm, and I want to submit. How to submit, I will explain. So first we have to what's called, first we have to define the gradient. Define gradient whatever gradient function. We have to pass x into the gradient function, and it will give the gradient value gx equal to what the gradient value 6x square plus 3. That means 6 into x plus 3, and you have to return your gradient value. So that is the gradient calculation. Okay. Now, so I have to initialize. So gradient descent algorithm initialization means, so you have to descent variable should be initialized. So I want to use import random. So x equal to random dot uniform. X equal to random dot uniform. Some value between the -10 to 10. That is okay. And you have to initialize eta equal to 0.1, and you have to initialize the epochs. Number of epochs or maximum number of iterations equal to, for example, I'm saying okay, 1000. So this initialization is completed. On the initialization completed, what we have to do? We have to write the iterative loop for iter in range of my epochs. Range of epochs. So we have to repeat the 3 iterations continuous, 3 parts, 3 steps we have to repeat. One step is gradient calculation. That is a gx equal to, you have to call this function gradient gx equal to gradient of x. Once you got the gx, then you have to calculate the del x. Delta x equal to minus eta multiplied by gx. And once you got the delta x, you have to update the x value, x equal to x plus delta x. So this process will be repeated until your 1000 epochs are reached. After that, you can print x value. Print x, you have to print. So something, some is not properly working here, but okay. Okay, so let us assume it is not a finally not converged, but okay, once you're completing this code, then what we have to do is, so click on share button. Okay, after that, here you can see the restricted. So anyone with this link. Okay, understood now? So otherwise I will go to share. Here by default you have the restricted. Now you can click on anyone with this link. Here by default it is coming viewer. So you have to click on the editor. You have to click on the editor. You have to click on the editor. Now what you have to do is copy link and done. Done. You copy link, right? Now go to your Canvas assignment. Go to your Canvas assignment. Once you click on that programming assignment one more thing, you have to rename it like a programming assignment 1, like that programming assignment 1, like that you have to rename it. And in that Canvas, you click on that assignment, for which assignment you wrote this code. So click on that one and click on submit assignment. Once you click on submit assignment, it will ask enter the website URL. So whatever the link you copied earlier, this copy link, that link you should copy there. That's it. Copy that link there and submit it. That's it. You don't do anything else. So I will verify that code what you have sent. If it is everything okay, then I will grade them. I will give the marks accordingly. Okay. So this is what I want to convey with you, because few are asking about these things. That's why. Okay. So this is from my side for today's session. So any doubts, please ask me. Otherwise, we will close the session and tomorrow we will meet again. Please. If you have any questions, please ask. Otherwise, we'll stop. Yeah. Thank you, Guru. If there is no questions, we will stop the session for today. And we will meet tomorrow.